calculate the frequency of the horizontal input when the vertical and the horizontal tangencies in a Lissajous pattern has been given. Now, we know for a closed pattern, the ratio between the frequency of the signal applied to the Y plates divided by the ratio of the signal applied to the X plates is going to be equal to number of tangencies in horizontal plane divided by number of tangencies in vertical plane, which in the numerical has been given as the number of tangencies in the horizontal plane has been given as 4 and the number of tangencies in the vertical plane has been given as 2, and the frequency of the vertical input has been given as 2 kilohertz, and he is asking us to calculate the frequency at the X plates. So this is going to be Fx, therefore is going to be equal to 1 kilohertz.
In this problem, the solution y equal to e power minus x minus 2x of a cos x plus b sin x. Therefore, we can understand that the roots are minus 2 plus or minus I. Now, so one root is minus 2 plus I, another root is minus 2 minus I. We have to find out. In the general solution, d square y by dx square plus m into dy by dx plus ny equal to 0, where the value of m plus n is the value of m plus n. So m is nothing but sum of the roots, so alpha plus beta. N is nothing but alpha beta. Now, alpha plus beta, by adding these two, you will get minus 4. By multiplying these two, minus 2 whole square minus I square, that is 5. Now, alpha plus beta is minus 4, alpha into beta is 5. Now, you have to find out the value of m and m plus n. Now, m is minus of alpha plus beta, minus of alpha plus beta is minus 4. Now, m is 4, n is 5. Therefore, m plus n is 9. Because sum of the roots is minus b by a, based on that, minus of alpha plus beta is minus 4, alpha plus beta is 4. Therefore, m is 4, n is 5, m plus n. The functional values of a function is given in the following table. We have to apply Simpson's one-third rule. F of x values are 0, 1, 2, 3, 4, 5, 6. Functional values are 0, 2, 6, 12, 20, 30, 42. Now, this is y0, y1, y2, y3, y4, y5, y6. We have to find out integral 0 to 6 f of x dx by Simpson's one-third rule, h by 3 of y0 plus y6 plus 4 into odd y1, y3, y5 plus 2 into even y2, y4. Now, h is 1, so 1 by 3, y0 0, y6 42 plus 4 into y1 2, y3 12, y5 30 plus 2 into y2 6, y4 20. Simplify this, you will get 90.
In this question, we have been given the overall T parameters, that's 3, 1, 5, 8. And we need to calculate the transmission parameter for the network N. Overall this, and we have to calculate this. So to calculate T parameter of this part, because both of these parts are cascaded. So if we, suppose we write for this transmission parameter as AA, and for this N we can write it as AA, BA, CA and DA. Then for this we can write as AX, BX, CX and DX. This should be equal to this whole 3, 1, 5, 8. So let us first find out the transmission parameter for this one. Let us, the current is Ix, this voltage is Vx, this is Vy and this current is Iy. From KVL, from this we have Vx is equal to Ix plus 2Ix plus 2Iy, so can be written as 3Ix plus 2Iy. This is the value of Vx, equation 1. From this we can write as Vy is equal to 2Ix plus 2Iy. We need expression in terms of, we want Vx is equal to Axi, Ax By minus Bxiy, and Ix is equal to Cxby minus Dxiy. This we are wanting to calculate. So we can write Ix from this expression, that is Ix is equal to 1 upon 2 Vy minus Iy. If you compare this and this equation, then Cx is equal to 1 by 2 and Dx is equal to 1. Cx is 1 by 2 and Dx is equal to 1. Now putting this value of Ix in the equation number 1. So we have Vx is equal to 3 into 1 by 2 Vy minus Iy plus 2Iy. This comes out to be 3 by 2 By minus 3 plus 2, that is minus Iy. This is the value of Vx. So comparing this with this one, Ax is equal to 3 by 2 and Bx is equal to 1. Now we have this value as 3 by 2 and 1 and 1 by 2 and 1, this, and AA, BA, CA, DA. This is for unknown network and this is 3, 1, 5, 8. So if we want to calculate this, we can take inverse of this. AA, BA, CA and DA is equal to 3, 1, 5, 8 and this 3 by 2, 1, 1 by 2, 1 inverse. On solving this, comes out to be equal to 2.5 minus 1.5, 1 and 7. Answer is C. So answer for this question is C.
The system can be obtained as question is to find that the open loop systems and closed loop systems stability. It is very clearly seen from the open loop transfer function that these open loop poles are in the right side of S plane. So open loop system is unstable. Whereas if the characteristic equation of the system is obtained, it becomes S cube minus 3S square minus 9S plus 11 is equal to 0. 1 plus G of S H of S is the formula. Characteristic equation also has got sign changes, which indicates that closed loop poles are in the right side. Closed loop system is also unstable. Answer to the question is D. Magnitude plot. Board magnitude plot of a system is given. The question is to find the open loop transfer function of the system. As we all can see that the initial slope of the board plot is minus 20, which indicates that it is a type 1 system. Hence, in the open loop transfer function of the system, there has to be a pole at origin, which will be placed along with the open loop DC gain. At corner frequency 1, minus 20 slope is changing to plus 20. It is becoming more positive by an amount 40, which is due to two zeros in the system. At corner frequency 3, plus 20 slope is changing to minus 20, which is because of two poles in the system, S by 3 plus 1 square. Now question is to find the value of K. Magnitude is given to be 10 dB at frequency 3. But to find K, we need the magnitude of this line, which if I can find at frequency 1, then it will be able to solve the question. So we can utilize this point magnitude to find the magnitude at this point using the slope formula y2 minus y1 upon x2 minus x1. From this, the value of m2, it can be obtained as 20 log root 10 by 3. From this m2 can be obtained to be like this. The magnitude of this line at frequency 1 is given to be 20 log k base 10. So we can say that 20 log k to the base 10 is root 10 by 3. So k is root 10 by 3, which when substituted there, answer to the question becomes B.
In the next question, a differential equation for the system is given. Now for this system, we have to check following statements. First of all, we will write down transfer function for the given system. If we will write down transfer function, then it will be ratio of y of s and x of s. Then it will be equal to s square minus 2s plus 1 divided by s square plus s plus 5. So it will be like this: s minus 1 whole square divided by s square plus s plus 5. We can rearrange denominator in this form: s plus 1 by 2 whole square plus 5 minus plus 5 minus 1 by 4. Now we can write down in this way: s minus 1 whole square divided by s plus 1 by 2 whole square plus root 19 divided by 2 whole square. Now we have to calculate pole locations here. Now if we will check pole locations for the given system, then it will be equal to minus 1 by 2 minus 1 by 2 plus minus j into root 19 by 2. Okay, root 19 by 2. Now first statement is, if the system is causal, then system function converges for sigma equals to minus 0.75. Now first of all, according to statement 1, if we will proceed, then this system will be causal. Now if we will write down ROC for the given system, then it will be like this: sigma will be greater than minus 1 by 2. ROC is always related to real part of pole. Here real part of pole is minus 1 by 2. So ROC will be related to minus 1 by 2. Since the given system is causal, then ROC will be right-sided. We can write down ROC in this form. Sigma should be greater than minus 0.5. Now, in this ROC, value of this sigma is not included. It means, and as we know that if in the ROC transform converges, and since the given value of sigma is not included in the range of ROC, then the transform will not converge. It means for statement 1, if we will proceed, then for the given value of sigma transform will not converge, because this value of sigma is not included in the ROC. So statement 1 is false. Now for statement 2, we need to find out inverse system. Now in the second step, if we have to find out inverse system transfer function, then it will be equal to 1 upon transfer function of given system. So it will be like this: s square plus s plus 5 divided by s minus 1 whole square. Now for the inverse system, if we will find out pole locations, then pole will be located at s equals to 1. Now if the inverse system is causal, now if we are assuming that inverse system is causal, then for stability. Now for stability of causal system, poles should lie in the LHS of S plane, and if this inverse system is causal, then its pole is lying in the RHS of S plane, so it is violating the condition for stability. So if we are assuming that inverse system is causal, then it should be unstable because pole is lying in the RHS of S plane. So statement 2 is saying the same condition, so statement 2 is correct. Now statement 3, we have already obtained the inverse system transfer function. Now for inverse system HIS, pole location is s equals to 1. And statement 3 is saying that HIS is stable. Now if HIS is stable, then ROC should include imaginary axis. For stability of system, ROC of system should include imaginary axis. For inclusion of imaginary axis, its ROC should be sigma less than 1, because as we know, ROC is always related to a real part of pole. In this case, for this inverse system, a real part of pole is 1, or pole is already real, so its real part will be 1, so its ROC will be sigma less than 1. Here sigma less than 1 we are writing down because we have to include imaginary axis for stability of system, and if we are writing down ROC in this way, then nature of ROC will be left sided, and according to property of ROC, if we are getting left sided ROC, then nature of impulse response HIT of inverse system will be also left sided. And if the impulse response is left sided, then it will not follow the condition for causality of system, because it will violate this condition. HIT should be 0 for t less than 0. This is the condition for causality of system, and this condition is not satisfying here because impulse response of inverse system is left sided. It means if we are assuming that HIS is stable, then this system should be non-causal. This system should be non-causal. And statement 3 is the same thing. It is saying that if the inverse system is stable, then it should be not causal. So statement 3 is also correct. So two statements are correct, 2 and 3. So answer will be option.
Circular loop is on is on Z is equal to 0 plane, having radius of the loop is 0.1 meter and resistance of the loop is 5 ohm, and magnetic flux density is 0.20 sine 10 cube t. AJ Tesla is given. Find value of current in the loop. That means he is asking induced current. Find I induced. So you know that EMF is minus d psi by dt, d magnetic flux, d by dt of minus of d by dt of magnetic flux, that is minus d by dt d of t into area of the loop is pi r square. So EMF is minus d by dt, B of t is 0.2 sine 10 cube t pi into 0.1 whole square. 0.2 0.1 whole square, d by dt of sine is cos 10 cube t into 10 cube. So here this value becomes, here minus also is there, so minus 2 pi cos 10 cube t volt you get. Now current you want, I induced is equal to, induced current is equal to EMF divided by resistance of the loop, that is minus 2 pi cos 10 cube t divided by 5 ampere you get. So after simplification, minus 0.4 pi cos 10 cube t ampere. So the correct option is
This question is about calculating the approximate bandwidth for common emitter amplifier, which I have drawn here. Now to know this bandwidth, we need to calculate the lower cutoff frequency and higher cutoff frequency. The difference FH minus FL will be considered as bandwidth for this RC coupled amplifier. We will first obtain lower cutoff. Lower cutoff will be calculated by considering this coupling capacitor, that you may also call as a blocking capacitor. We connect this to provide DC isolation to this biasing circuit, and we find FL by considering the effect of this blocking capacitor or coupling capacitor. And to find this lower cutoff, I have drawn the equivalent circuit. This is only the equivalent circuit of the input side. This is coupling capacitor. On the left side of it you will see source impedance and the signal source, and on the right side of coupling capacitor you will see RB and then RI. That RB is the parallel combination of R1 and R2, 40 parallel 40, that will be like 20 kilo ohm, and Ri will be the input resistance of this amplifier, the resistance which I see from here. And everyone knows from the small signal analysis of this common emitter amplifier, without bypass capacitor, that input resistance will be equal to HIE plus 1 plus HFE into RE, or you may write it as R pi plus 1 plus beta into capital RE. And this can be calculated by putting the data provided. R pi 2.5 kilo ohm plus 1 plus beta, that is 101 into RE 0.5. It will be 50.5 plus 2.5, that should be 53 kilo ohm. And then we can obtain lower cutoff frequency. Lower cutoff frequency or lower 3 dB frequency, it will be of the form 1 by 2 pi R into this capacitance, that you may call as coupling capacitor or blocking capacitor. And that R is resistance seen by that coupling capacitor under the condition that signal source is deactivated or disabled. So let me deactivate this signal source. When I deactivate this source, then the resistance seen by this coupling capacitor will be Rs plus this parallel combination. I will write here where R is equal to Rs plus parallel combination of Rb and Ri. This is the resistance seen by this coupling capacitor under the condition that signal source is deactivated. And this can be calculated by putting all the values, that Rs is 0.5k plus Rb 20k and input resistance Ri 53k. If you calculate this combination, it will evaluate to this and 53, that will be equal to 14.52 and then plus 0.5.